Well, good afternoon. Thank you for joining us today here for our virtual field day. We're excited to be highlighting a great project located just outside of Ames here. Hello, everyone. I'm Liz Ripley. I'm the Conservation and Cover Crop Outreach Specialist for Iowa Learning Farms. And I want to welcome you all today to our virtual field day. A little bit about Iowa Learning Farms, for those of you that may not be familiar with us, welcome. We were established in 2004, and our goal is to build a culture of conservation. And that's by working with farmers and landowners and researchers like those you're going to hear from today to implement conservation practices that help improve water quality and soil health while remaining profitable. These events are made possible through our great partners, which include the Iowa Department of Agriculture and Land Stewardship, the USDA Natural Resources Conservation Service, Iowa State University Extension and Outreach, the Leopold Center for Sustainable Agriculture, Iowa Department of Natural Resources, US EPA Section 319, Conservation Districts of Iowa, Iowa Farm Bureau, Practical Farmers of Iowa, GrowMark, Iowa Agriculture Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center. So as we get going today, the way it's going to work is I'm going to highlight a video that was shot out in the field at this pumped bioreactor. And at any time during the video, feel free to submit your questions via the chat box. I'll take those and we'll get them asked of Lindsey and Natasha, who are here with us today. Following the video, so during the video, I ask that you keep your microphones muted and your videos off, but following the video, if you have questions that you would like to ask directly to Lindsey or Natasha, you are invited to unmute and ask them that way as well. So again, at any time, feel free to submit questions by the chat, or there'll be an opportunity to ask them vocally after the video. So following today's video, virtual field day, you will be receiving a brief evaluation via email. We ask that you send that back our way so that we can continue to improve future virtual field days. Today's virtual field day is being recorded and will be posted to our YouTube channel following today's event. So if you know someone that was wanting to be here but couldn't join us, you can feel free to share the link that will be in that evaluation email with them to check it out themselves. So without further ado, again, welcome. It's a pleasure to see you all today, and we'll take a look at this pumped bioreactor system.
My name is Lindsey Hartfiel. I am a Ph.D. candidate at Iowa State University in the Department of Agricultural and Biosystems Engineering. Today we are at what we call the UTHI dual chamber bioreactor. It's located about 25 minutes southwest of Ames, Iowa. And as a dual chamber bioreactor, this is essentially just two bioreactors that are connected in parallel. So in the context of Iowa, our bioreactors, they typically intercept our subsurface tile drainage from our row crop fields, and we route the water through the bioreactor, where the bioreactor has a carbon source, typically wood chips, but sometimes some other kind of carbon source, and that acts as a food source for beneficial denitrifying bacteria, and those bacteria then work to convert our nitrate into a harmless nitrogen gas. Typically, these bioreactors have a single chamber, just one inlet structure that we use to control the amount of water entering the bioreactor, and then one outlet control structure that helps to regulate how long that water is in the bioreactor for. As a dual chamber bioreactor, this one actually has three inlet structures. One we call the main inlet that routes the water into two smaller inlet control structures that then set the amount of water going into the two bioreactor chambers. And then there's the two outlet structures as well for the two chambers. So this bioreactor, it was designed using the NRCS design standard. It had a large 14-inch tile coming into the system, but it turns out that the 14-inch tile is actually larger than what the drainage system actually required, and so we had historically had much lower flow rates than we had expected. So we saw complete nitrate removal pretty often at this site. So to add some additional flow, try to get some additional nitrate treatment, we added in this pumping system. As we've monitored this creek here for the past 3 summers now, while we're collecting samples from our bioreactor, and the creek has nitrate concentrations pretty similar to our tile drainage coming into the bioreactor. Okay, so this creek is Big Creek, and in The first part of our system is we have a large, pretty coarse filter just to keep large debris out of the system. We opted to not include a smaller, fine filter to keep the sediment out because we felt that the system would probably get clogged pretty frequently and add some strain to our pump. So we did not include that. But from there, it goes into our pump, which is behind us on an elevated platform. Because this site is so close to the creek has flooded and gone out of its banks on top of the bioreactor. So we had to raise our pump up to keep it out of the floodplain. And also inside that box is flow meters that we use to know how much water we're pumping from the creek. Then we have valves to kind of restrict the flow to how much the bioreactor is needing at the particular time that we're using it. And from there it goes into our two separate water control structures for the two inlets. So we have the flow monitoring from the creek up in the box, and then down below us back here there are the two outlets, and those also have flow monitoring in them, so we can figure out, based on what we're pumping from the creek, what we're seeing coming out of the outlet, how much was tile drainage, how much was from the creek, and the main inlet has that tile drainage coming in, so we can see the difference between the two concentrations. We collect our water quality samples weekly at this site as grab samples. So this site also has 9 random sampling wells per bioreactor chamber. And so we can collect samples throughout the length and width of the bioreactor to know what's really going on inside the bioreactor. So we will pump our wells out, make sure we're getting a fresh sample, and then collect samples from there, as well as the inlets and the outlets. So we only recently got to use this pumping system because this year we've had a lot more rain than we've had in the past couple years, and pretty timely rain every week or so. We were getting pretty decent storm events. So we've only recently been using it, and as we're treating a surface water source, the water is a lot warmer than the tile drainage, and also the creek has sediment in it, which has carbon in it. So by pumping the water from the creek, we have higher temperatures and higher carbon, so that really makes our bacteria really happy, and they really like to do their job and convert that nitrate to nitrogen gas. So we saw in the times that we've been using this really rapid denitrification. We have complete nitrate removal in the system. Yeah, we don't want to see complete nitrate removal. We'd like to see a little bit of that nitrate still left in the system, because once the nitrate is gone, it allows for other microbial processes to occur. So one of those is sulfate reduction. That one's linked to methylmercury production in other freshwater systems. And methylmercury is a really harmful water pollutant as well. So we would essentially just be trading our one water quality problem potentially for another. So that's something we'd really like to avoid. Another thing that can happen is we can see methane being produced in these systems as well, which is a greenhouse gas that we'd really just not like to see being produced. Are we concerned about the sediment entering the bioreactor if that's going to clog the bioreactor up? So it is something we're monitoring for. We did some tracer tests before we started the pumping system this year to see what the flow parameters are like in the bioreactor right now, what its hydraulic properties are, and then we'll monitor again to see if it has changed as a result of sediment entering. There's the two chambers, and chamber B is located at a slightly lower elevation than chamber A. When they installed it, tried to make it level, but in the installation that didn't come out totally to fruition. So chamber B, when there's low flows, gets more water than chamber A. So in chamber A, we've monitored 2019 through now. So looking at 2019 to 2021, we have seen essentially complete nitrate removal when we look at median or average concentrations in chamber A. But chamber B is the one that's been more variable, best performance in its first year, and then it's been getting a little less in terms of nitrate removal over time. I think one of the main things that we hadn't really considered is, as a surface water, it's warmer, it has that higher carbon. So I think that's the biggest thing to really consider in the timing of using the pumping system. If you're trying to select a source, something to consider. While the tiles are flowing, the creek has really good high nitrate concentrations for this purpose, to pump and treat it. But later in the year, as the tiles stop flowing, the creek gets lower and doesn't flow as much. We see lower nitrate concentrations. So selecting a good pumping source is important in it, and then considering the timing of when you're going to be using it. So if you're using surface water, it would be more ideal for early spring or early summer before the water temperature gets really high, especially because it does have that extra carbon that the bacteria like to use. So this system, we do have to manually come out here, turn it on, turn it off when we need to. So this one also, we designed it with flexibility because it was the first pumped bioreactor here in Iowa. So we wanted to make it flexible that we could make adjustments if needed, change it, and that we can take it down for winter so we don't have to deal with components freezing. Yeah, if this would become a proven concept and we'd figure out the best timing to use it, best sources to be pumping, it could become more automated and less of a manual need to turn it on, check it, turn it off when needed. Yeah, the hope with these pumped bioreactor systems is that we can extend the use of bioreactors beyond just subsurface drainage, which is really their only application so far here in Iowa. So some of those could be treatment of surface waters that have high nitrate levels, if we can figure out the timing of that. And then, or something like irrigation waters, or if we're collecting storm runoff that has high nitrate, something like that, where we could treat additional amount of nitrate, because we do have such a high nitrate loading to the Gulf of Mexico, trying to reduce that. All right, so in these white PVC sampling wells, we also have some wood chip bags that we are keeping in them so that we can monitor how the wood chips are degrading over time. And with this pump system, we believe these sampling, the bioreactor itself could potentially have an extended life because the pumping system could provide a more consistent, constant flow rate, where these tile drainage systems typically, at this point in the summer, they'll stop flowing and then they can sit dry for a long period where the wood chips can then break down. So if we can keep a more consistent, constant flow to the bioreactor, we do think it has the potential, with the right application, that it could extend bioreactor life. This site, we're gonna continue pumping. We'll probably shut it off here pretty soon this summer as the nitrate levels are dropping in the creek as well. But if we do get high nitrate concentrations come this fall again, we'll turn it on, use it again, and then we'll see how things are going. But we might turn it on again next year to get another year of data on this particular pumping system.
All right. So once again, if you have questions, feel free to submit those in the chat or simply unmute to ask. And at this point, Lindsey and Natasha are going to be joining us for the discussion. So some questions that have come in so far. Any thoughts as to why, you mentioned, Lindsey, in particular, that the decline in chamber B's ability to remove nitrate? Any thoughts or reasoning as to why that might be?
Okay, yeah, that is something we'll typically see in bioreactors. Over time, their first year or two, they'll have really high performance. That's because the carbon source, the wood chips, that it's a new source. The bacteria can use that carbon a lot better in those first couple years. Later on in its life, the carbon's less available to the bacteria to use. So we'll often see the performance of bioreactors decline over time.
Sorry about that. Go in here. So maybe for both of you, what, Natasha or Lindsey, has surprised you most about this particular project in your experience with other bioreactor systems?
For me, this is the first bioreactor I really worked with as part of my PhD. And initially, everyone was really surprised by how much nitrate this bioreactor is removing and the lack of flow that it was getting. So that was kind of surprising, but I think it's allowed us to, really do some unique stuff with it. Looking at, a worst case scenario, what's going to happen in this bioreactor when it's not getting the flow we want. And then to be innovative and look at these pumped bioreactor systems It's been a really interesting site to monitor and do some innovative research on.
Yeah, I would agree with Lindsay on that. We've learned a lot from this bioreactor. It's given us a lot of surprises. I think the biggest is the low amount of flow we've got for the size of the bioreactor itself.
So some economics here. Have you crunched the numbers? They're curious, what's the pumping cost per acre inch and or cost per pound of nitrate removed in the pumping system versus the unpumped system?
I'm starting to crunch these numbers, but the pump bioreactors, it's new. We don't even have like a full year of data. This particular site, we got to run it for 3 weeks because earlier in the summer, the creek flooded out of its bank twice. So we really didn't have to pump as much as we had thought we were going to this year. So we don't have a ton of data for it, but there's another pumped bioreactor in Illinois that we're working with, and crunching the numbers. We're running a bunch of different scenarios, like if the pumped bioreactor would have a higher removal rate of nitrate, or if you could use it for a longer period of time in the year. Also, like what is it gonna do to the life of the bioreactor? Will it have a shorter life, a longer life? But a lot of the scenarios, it's a little bit more, I would say like maybe $1 to $5 more like per pound of nitrogen removed. But pretty comparable overall. Most of the scenarios we're looking at, it seems to be fairly comparable to a wood chip bioreactor cost. Just it'll be a little bit more because yeah, you are pumping, you have to pay the cost for the pumping system in addition to that bioreactor.
In the case of your site there, you were able to hardwire in for electricity, correct? Or were you using solar?
This site, yeah, we did have the power company come in and we got power out at the site. It's right along the road, so we didn't have to have the power go too far to get to the site. I know the one in Illinois, they are using solar power. The challenge they have there is that the solar panels will provide enough power during the day, but during the night, the bioreactor, the pumping system typically shuts off because it runs out of power. So that's the challenge with the solar panels.
So speaking of the pump, what kind and size are you looking at in terms of recommending for this kind of system? What kind of horsepower are you looking at?
The pump we're using is a 7.5 horsepower, but the bioreactor at our site is very large compared to most bioreactors. So I think most sites would probably get away with a smaller pump than that. Size, yeah, would depend on how the bioreactor was designed and what its design flow rate is.
In terms of designing this bioreactor, can you remind us when was the original system installed?
It was installed in the summer of 2018.
Okay. And have there been any changes upfield from where the bioreactor is installed since, like it was designed in probably 17, but then now has there been any infield changes that may be in fact impacting the amount of nitrate coming in?
The only major change, I think this year they started doing no-till on the field out it's draining. But we did add an additional tile line into the system in 2020 as well. I recently learned from the NRCS person who designed it that when they were installing the bioreactor, they did learn actually that 14-inch tile line just connects directly to an 8-inch tile line. So that's why the flow is so much less. It's actually an 8-inch tile that turned into a 14-inch tile. So, yep.
So are there permitting and or legal considerations when you're pulling from a surface water body for this kind of system?
Yes, we did have to get a water use permit from the DNR. I think this will vary state to state. I don't think Illinois, their pumped bioreactor, I don't believe they had any permitting they had to do. I think Laura Christensen is online, so she can speak to that if she wants to. But we did have to get a permit from Iowa DNR. And it's essentially how much water we're gonna, at a maximum, be extracting, like rate and volume of water we would be pulling from the creek.
To add to that, we did get notification also to not pump later on in the season because there wasn't enough water in the creek. So kind of restrictions that way as well.
Laura, would you like to chime in at all on your system in Illinois in terms of any legal considerations?
Hi, yep, can you hear me?
Yes.
Thanks, Lindsey. Really well done, Lindsey. I really enjoyed watching that video. We did check with Illinois EPA to make sure we weren't going to cross any boundaries, and they checked with Illinois EPA legal team, and they're okay with it. But it was good that we had checked with them. We didn't have to do anything extra, but it was good that we had checked with them. So I'm glad we did that. Thanks.
So you'd mentioned in the video, which we filmed, I believe, in August, any changes in your plans to possibly turn that on this fall?
We didn't get enough rain this fall to be able to turn it back on. And as Natasha said, we had heard from DNR that we weren't allowed to pump because the levels in the creek had dropped too low. And our permit, it runs from April 1st to September 30th each year. So we're past the point that we would get to use it.
Is there an aspect of this project looking at wildlife impacts downstream from the pumped system? Or potentially future consideration, I guess, for this research project?
Maybe a future consideration, but we do not have that as part of the project right now.
And then I guess we focus primarily on water quality, but I know you're measuring a lot and monitoring a lot out at that site. So have you seen any changes in some of the other components that you're measuring at this particular bioreactor site?
So yeah, some of the other things besides nitrate that we monitor for, in terms of like environmental conditions in the bioreactor, we monitor for the temperature, the dissolved oxygen level, because for the denitrification to occur, we have to get rid of the oxygen in the system first for the bacteria to then convert the nitrate. So we monitor that, and then temperature and water level are the other two things we monitor in terms of the environment or in the bioreactor. And then in terms of other pollutants, we're monitoring for methane and nitrous oxide in the water, which are both greenhouse gases, and then sulfate levels. And we do monitor E. coli, so some bacteria. I will say, in terms of bacteria, the creek had really high bacteria concentrations. And again, this is only 3 weeks of data, so really early results here. But it was removing a lot of the bacteria. If you're familiar with that, they call it colony forming units per 100 milliliters of water is typically how they report it. And the bioreactor was removing over 500 colony forming units per 100 milliliters of water. Again, really early results. Don't know why it's doing that, but that was something we saw. A lot of nitrate being removed, and then so because all that nitrate was being removed because we were using it late in the summer when the temperatures were warm, we did see that methane being produced and the sulfate reduction happening. So those are something that with these pumped bioreactors, timing and the pumping source, like the water we're pumping, those are things we have to work on figuring out yet.
So curious here, at its warmest, how much did the stream temperature vary from your tile drainage temperature?
The tile drainage was around like 55 degrees Fahrenheit, and the creek was around 80 degrees Fahrenheit. So it was a big jump.
What do you suppose, I know you were not quite sure, but could there be the possibility that those microbes are adding to the colonies within the bioreactor system, or are they finding it inhabitable in that system and dying off?
Yeah, there's kind of two working theories on bioreactors' potential for like removing bacteria. First is that maybe the E. coli are being outcompeted in the bioreactor, so they die off. The second is maybe some kind of filtration with the wood chips themselves. Mechanism isn't really sure. It was one of the original early goals at this site when they first installed it in 2018. They thought there was a lot of manure application upstream and we might see high bacteria levels coming in, but that also wasn't the case at this site.
I'll pause now in case anyone would like to unmute to ask a question. Again, feel free to continue submitting questions in the chat box. All right, well, here we go. Got another one that just beat me to it. How often does the carbon by way of wood chips need to be added to the bioreactor or exchanged out? So maybe current systems and what maybe your hypothesis would be in this pumped system as it may extend the life.
Okay, so bioreactors are still pretty new. Oldest ones, I would say, are around like 12 years old in Iowa. And some of those are now, needing a replacement. So probably around 10 years. But there are some bioreactors that have had to be replaced after like 5 to 6 years. So I'll say around 10 years, but it's still a new practice. They're still kind of narrowing down how do we know when it's reached the end of its life and when do we have to replace those wood chips. In terms of these pumped bioreactors, so there's, I guess, 3 options here. Maybe it has the same life as a normal bioreactor. There's the alternative that we could have a lot of sediment coming in and it could actually shorten the life by clogging up the bioreactor so the water can't come in. I think that concern could be fixed with a good filtering system, or if you have a different pumping source than like surface water, if you were treating groundwater, you'd probably have less sediment concerns. And then on the flip side, it's that it would extend the life. How long? Maybe 5 years. I don't really know for sure. And the reason we say it could extend it is because the research is showing that the wood chips near the inlet are usually the ones that break down the most. And those ones are subject to the biggest fluctuation in the water level. And once the wood chips are allowed to dry out, that's when they'll break down pretty rapidly. So trying to keep it consistently saturated by using a pumping system, we think maybe there's that potential to extend its life.
So there's a question here, and maybe you mentioned it, but how do you know that the carbon was sediment bound rather than simply carbon in the stream water itself? Were you collecting samples to be able to separate that out?
We didn't separate it out. We measure the total organic carbon in the water, but we do know there's sediment coming in. Just visually looking at the water, we can see it when we collect our grab samples from the creek, but we have not documented for sure the amount of sediment coming in.
And again, kind of maybe you mentioned this, but just a refresher of how often are you monitoring the inlet outlet to measure the changes that are occurring?
We monitor it weekly.
And how is that done for those that may not be familiar with how that process works?
So our monitoring, we go out there weekly from the creek. We're collecting grab samples. So putting a bottle in the creek, filling it up with the water, take it back to the lab, and we'll plate it for bacteria and then save some of the sample to be analyzed for the different water quality things we're looking at. And then we do the same thing at those inlet and outlet water control structures. And then there were those white PVC wells that we also collect across the bioreactor. And those ones we have to pump them out with a little pump to make sure we're getting an accurate fresh sample, not just water sitting in that well for a long period of time. And then we'll collect a bottle of water from those as well and take it back to the lab to be ran.
So not a small task, what it sounds like. All right. Let's see. I think we hit on most of my questions. So again, folks, if you have questions, feel free to unmute and ask Lindsey and Natasha. or submit them in the chat. In the meantime, for those of you that joined us today for your CCA credits that were being offered, you can go ahead and email those to me by 5 p.m. today. And that's my email. I'll put it in the chat as well so that you can easily send that email to me. I just need your name and the name you entered to watch the webinar, today's virtual field day, if it's different, your CCA number, and then I will get that submitted on your behalf to make sure that you get your credit. So let's see. And then Lindsey or Natasha, if you want to put your emails in the chat as well for folks, or send them my way and I'll put them in the chat for everyone. So if they do have specific follow-up questions, they can certainly reach out to you. And I've got one more slide while you're preparing that. So if you are interested in potentially installing a edge of field practice like a bioreactor on your property, feel free to submit your email, name, and information to me. Again, that same email I put in the chat, and I can help connect you with the Iowa Department of Ag and Land Stewardship to get a practice installed on your property, or see if your property would work for one of these practices as we work to reach our Iowa emission reduction strategy goals. So I'll be putting Natasha's email here in the chat. You can also find all of us on the directory at Iowa State University. So let's see, and here is Lindsey's as well. So again, thank you all for tuning in today. I'll give just a couple more minutes or seconds if folks want to submit a question directly while we're all here. And again, this is being recorded, so it's going to be uploaded to YouTube. So feel free to share out the link, both of today's discussion and the video that was featured, so that other folks who couldn't join us today can take a look for themselves and learn about this really innovative idea of pumping water into a bioreactor system. And hopefully we'll continue to learn more about this potential project between this site and the site in Illinois as we test the feasibility of these systems as another way of helping meet the goals of reducing nitrate loss downstream here in Iowa. So any final words, Lindsey or Natasha, you'd like to share with the group before we sign off today?
I'll just say thank you to everyone for listening and for your interest in this project.
Any final words, Natasha, you want to just tag on?
Yes, thank you. Thank you for coming.
Excellent. Well, again, thank you all for tuning in today. It's a pleasure. We have more virtual field days in the docket, so please stay in touch with our systems and we'll make sure you get those invitations. We'll see you again soon.